All right, we're going to solve this equation on this bell work. Remember from last time that if we got a power of 2 with a variable or unknown like we do here, and we do expect this to have two answers. So the first thing I'm going to do is I'm going to try to isolate this b squared. Okay, so I'm going to use some principles of equality to do that, just like we were if we were solving it for just b instead of b squared. It's just, we're going to add another principle of equality right there. So first thing I would want to do is to be able to drop this negative b to the power of 2. So let's see if we can do that here. Drop it like this, okay? So we're going to drop that, which means the minus 1 needs to be zeroed out with plus 1. Okay, so I put that plus 1 there, which means I need to use this as a principle of equality by adding 1 to the other side as well. So negative 6b squared is going to equal negative 169 plus 1 is negative 168. So we're pretty close to getting the b squared by itself, but we still got the negative 6 coefficient with it. So I'm going to have to make that go away as a phantom 1. So to do that, I'm going to divide it by itself. Divide by negative 6, but if I do it to the left side, I must do it to the other side as well. So divide by negative 6. There's 1. This leaves me with just b squared. And that's going to equal, in my calculator, I'll do this 168, negative 168, divided by negative 6. And it tells me it's 28. Okay, now that's b to the power of 2, but what we really just want here is just b. Okay, b equals something. So remember, to get rid of that power of 2, or to undo it, you got to square root it. But if I square root one side, I must square root the other side as well. Now last time, if you watched the video, you saw how to put this into the calculator. I pushed the second button and then the x squared button. It's just one button to the left of 7. And then I can type in 28, and the calculator will simplify this for me, and it shows me that it is 2 times the square root of 7. Okay? Now that's a pretty good answer, but remember what I said in the beginning is if we have b to the power of 2, we do expect this to show 2 different answers. So it's not just 2 times the square root of 7, one answer, but we also have to take the opposite of that too. So negative 2 times the square root of 7 would be the second answer. And now we have both answers, which means that if you go back to b squared here and replace it with 2 times the square root of 7, put it in parentheses, of course, that you would get a true statement. Same with putting in a negative 2 times the square root of 7, replacing that with b, you get a true statement. Okay, and the reason why that's important is that that tells us that these two answers there are 2 solutions that would make this a true statement. All right, there's our 2 objectives for the day. I can find the length of a hypotenuse on any right triangle, and also I can find the distance between 2 points on a coordinate grid. So take a minute and copy these down, please. So a little bit of new vocabulary with this objective. That's a weird word, right? Hypotenuse. Yeah, but right triangles. Hopefully you remember that's just a triangle. A right triangle is just a triangle that has one 90-degree angle in it. Hopefully you learned that in 7th grade, but if you didn't, that's fine, because there you go. I just told you what it is. And then we'll look at a coordinate grid and how this right triangle stuff relates on it, which if you look at 2 lines or 2 points on a graph, you make a line between those 2 points. There was always a right triangle in there, you just probably didn't notice it before. So again, with a right triangles are so unique mathematically speaking that math nerds a long time ago said, we got to give it its own vocabulary stuff right here. So welcome to math class. And the first thing we're going to talk about here is legs. Okay, so these legs. And you see that these 2 sides are labeled legs. Now, the thing about a right triangle has one angle that is a 90-degree angle. Angle, sure. Okay. And it can only have one angle that's a 90-degree angle. There's reasons for that, but we're not going to go over that today, okay? Now, a 90-degree angle on a triangle is generally shown with this marking like this. Okay, just a little box like I've shown here in green. They're not going to show this, but you could always say that that's 90 degrees right there, okay? Now, the reason why that's important is because the angle, the 90-degree angle, will tell us which parts of the triangle are legs and which one is the hypotenuse. We can see that just from this drawing right here, the legs are the 2 sides that create the 90-degree angles, but they're both considered legs. Okay, so a leg is a side on a right, and it has to be a right triangle, that make up the 90-degree angle. Okay? I said a side, but you could say the sides on a right triangle with two sides, even if you'd like. It's up to you. Okay, as long as we understand that the two sides on the right triangle that make up the 90-degree angle are called legs. Now, the reason why that's important is because not only today, but next lesson, and then on the review and test, we're going to be using this vocabulary a lot, legs and hypotenuse. So when we say it, we just expect you to know, if I say leg, we're talking about the side on a right triangle that makes the 90-degree angle, one of the sides, okay? Now, we also have this other word, and it's a pretty funky looking word right there, hypotenuse. See if I can spell this right. Not that I really care, but hypotenuse, okay? So there's a few different ways to describe the hypotenuse. And I guess one of the ways is, I kind of look at this 90-degree angle like it's pointing at the hypotenuse right here. So I'd say, look, see how it kind of points at the hypotenuse? Another way to say that is it's opposite to the 90-degree angle. The side of a right triangle that is opposite to the 90-degree angle. You could also say, well, let's see, you could say that you could say indirectly that it is the side of a right triangle that does not make the 90-degree angle. And so I'm giving you guys a lot of options here, but just choose the one that works best for you. And also, it may be important later to understand it's the longest side of a right triangle. Okay? I'll stop there. I mean, I could keep going, but I get the feeling you guys don't want me to, so I'm not. But that's 3 different ways to describe the hypotenuse, whatever works for you. Okay? Now, the other thing about these triangles is that sometimes they change the orientation on them. Okay? So, in other words, what this means is that you could have 2 sides like this, and then this side right here. And I purposely used the colors here to show that the 2 reds are the legs, and the purple is the hypotenuse. But they may not show that this is the 90-degree angle. You can always put that there if you'd like. And yes, we are pretending like my drawing is nice, but either way, okay? But you have to know, you need to know what a 90-degree angle looks like. I don't know, an L, a T, whatever you want to call it, but the angle's 90 degrees, boom. Okay? So as it turns out, with right triangles, legs, and hypotenuse, we have what we call the Pythagorean theorem. Well, that's another funky word here, right? Pythagorean. Well, Pythagorean comes from the person Pythagoras, who lived in ancient Greece. Not that I think you care, but here we go. So, Pythagoras was kind of like the king nerd back in ancient Greece, and back in those days they didn't have Xboxes and Call of Duty. So what did they do? They got together and they did math. So the group, I mean, they started to really gain some traction there, these group of nerds. And so what they did is they started, they'd post signs on saying, hey, we're going to get together and we're going to do some math with triangles. You got to come join us. And then people actually would join. Can you imagine doing that? They would post signs about their get-togethers on light posts and stop signs and stoplights and stuff. And people would actually come to these nerd parties, okay? Well, they loved them so much and they started to get so big that, and of course, like I said, Pythagoras was kind of like the king nerd, so it was kind of a powerful group, actually. So powerful, in fact, that there was one time where a person challenged Pythagoras on something. It was actually based on rational and irrational numbers. Again, not that I think you care, but Pythagoras, now being such a powerful person with such a large following, didn't like that he was being questioned. So what do when you have power and you get questioned? You choke the dude out in water, and he died. He drowned to death. So The interesting thing about that, too, to me anyways, because I'm a nerd, is that we find that Pythagoras was actually wrong and the dude challenging him was correct. So, especially when you're wrong and someone challenges you, boom. I'm not saying you should. Like, never choke anyone. Never choke anyone out in water. Okay, so there you go. There's a little background on Pythagoras and the Pythagoreans. But the Pythagorean theorem itself is older than ancient Greece. It goes all the way back at least to ancient Egypt as well. Well, as it turns out, if you were to take the two legs and square them, meaning to the power of 2 there, like we see mathematically speaking, and you added those two legs as squares, then you would have the same as the hypotenuse squared as well. And when I say squared, it actually is quite literal right here, meaning that, let's see if we can show this here. Let's take this drawing and move it over here, and let's pretend like my drawing is good. Okay, so with this, if I were to take this leg right here and make it a square, and I'm trying to use technology to make this work, that seems okay. And then this one also, this leg, if I were to make a square out of that side length, then as it turns out, if you were to make a square out of the hypotenuse, and again, just please pretend that I'm drawing a nice square, the area of the two leg squares, like if you were to take these two legs squared, it would fill up this hypotenuse as a square altogether, okay? So it's actually quite literally, if you were to square the legs and add those two areas together, you'd get the hypotenuse area as a square, okay? Not that, again, not that you may not care about that stuff, but maybe it'll help you to remember leg squared plus leg squared is the hypotenuse squared. Some people prefer to think of this as a squared plus b squared equals c squared, which I think sounds even more nerdy, but people seem to remember that better. So if you want to think about it that way, that's fine. And it's true if, well, I guess we won't be using a lot of principles of equality today, except maybe the square rooting on both sides. For the most part today, we're only going to see order of operations, okay? And really, the only operations we're going to see from the order of operations is that you need to understand you have to do exponents, and then you can add, okay? So we're going to be getting the legs today, solving for the hypotenuse pretty much strictly today, and then you're going to square the legs, add them together, right? Because that's the order of operations, and then we'll use the principle of equality on both sides. Okay, now I don't really care if you think about it as a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. You just have to know it, okay, because it's going to be required not only on the assignment, but also on the mastery quiz, which is going to be based on today's lesson and then the lesson for next time. Well, as fun as that was, let's put this into some practice right here, okay? So leg squared plus leg squared equals hypotenuse squared. There's the Pythagorean theorem. And right here, we can see that they've given us this leg right here, 3. So I'm going to say this leg right here, boom, 3. Well, what if you wanted that leg to be 4? It doesn't matter. It does not matter which leg you say is which leg. A leg is a leg is a leg. So the second leg for me then is going to be 4. Again, not that you had to do it this way. You could have put the 4 there, and then the 3 there, and then added them together. But we're going to square them either way. And again, the whole idea here is that these two squares added together, boom, that's the hypotenuse squared, okay? Now we are trying to find the hypotenuse. We don't want the hypotenuse as a square, but we'll get the area out of this. And I know that 3 squared, that'd be the same as 3 times 3, which is 9. Okay, of course you could just use the calculator for that. And then 4 squared is 4 times 4, try to make that a little bigger, 16. Okay, and again, if I add those two, it would be the areas of the squares together. That's the hypotenuse as a square as well. Well, 9 plus 16 is 25. You can put that in the calculator if you need to. It's not something you should feel ashamed about. In any case, though, that's still the hypotenuse as the area of the square for the hypotenuse, okay? But like I said, we do not want the hypotenuse squared. We want just the hypotenuse. So to do that, to get rid of that hypotenuse to the power of 2, that's where we use the square root here, okay? It's just if I do it to one side, I must do it to the other side as well. This leaves me with just the hypotenuse. Again, it's not the hypotenuse as a square, but the square root of 25. Put that in the calculator. is 5. Now, I'll go back here. If you were to put the 4 as the first leg and the 3 as the second leg, you're still going to get a hypotenuse that's 5. Okay? Because remember, leg, doesn't matter which leg you say is which. They're legs, and that's all that matters. So let's find the hypotenuse of this one. And yeah, they've given us 2 legs right there. They won't be colored on the assignment, but it looks pretty right here. So I'll say that the first leg for me, I'll just say it's 14. You could say it's 10 if you wanted to for some reason. I'm going to say it's 14. The second leg will be 10 for me. Okay, so I'm just replacing those legs. We know those values, so we put those values in. Now if we raise them to the power of 2 and add those together, well, that would be the same as the hypotenuse to the power of 2 as well. So in my calculator, because I don't know what 14 to the power of 2 is, but my calculator does. Put this into the calculator, it's 14 to the power of 2, which shows 196. I know 10 to the power of 2 is 100 though. And, well, there you go. Add them together, it's the hypotenuse squared. Okay, well, let's go ahead and add those together. So 196 plus 100 is 296. And again, this is the hypotenuse squared. Well, we don't want the hypotenuse to the power of 2. We just want the hypotenuse, so square root both sides. Okay, and again, square root of 296, I don't know what that is, but I know the calculator does. In either case, though, it's going to give us just the hypotenuse, which is exactly what we want right here. So in my calculator, for those of you that don't remember, to put the square root symbol in there, push the second button in the top left in green, and then one button to the left of 7 is the x squared button. When you push that, you'll see the square root symbol pull up on the calculator. And I just type in 296, enter, and it has already simplified the answer for me as 2 times the square root of 74. Now in the past, for the first 2 lessons, we had to simplify that ourselves. But now we know that the calculator will simplify that square root for us. Very convenient. I should have read this earlier, but the answer on this one, it doesn't want just the simplest radical form, it does, but it also wants the answer round to the nearest tenth. So we need to see the decimal value of this. It's an irrational number, which means the decimal goes on forever and ever, never repeats or terminates, which was, what was that, the 3rd lesson in this unit? But I can change this into a decimal with the calculator. In the bottom right where you see the enter button, just right above it is the double arrow button. If you push that, it will change the decimal, change it into a decimal value, which for me, it's showing 17.20465053. And depending on the calculator you may have, it may even show more decimal or less decimal places. It's just on this one, it said to round to the nearest tenth, which is where the 2 is right there. So I look one place value to the right, which is a 0, which means the 2 is going to stay the same, and I can get rid of everything else to the right of that place value. So 17.2 would be the decimal form rounded to the nearest tenth. 2 times the square root of 74 is more exact, but either way, okay? There are our 2 answers. So on the assignment, if you get 2 times the square root of 74, there'll be a square root button that you just push, and then you can type in the 74, but put the 2 in there first. All right, same thing on this one. Now notice that one of the side lengths is already in a radical form. No problem, because the calculator will do that work for me, okay? So my first leg, for me, I'm going to say is 3 right here. If you wanted to say it was 2 times the square root of 10, you could. For me, it's 3. Okay, my second leg is going to be 2 times the square root of 10. Now, generally speaking, we'd just say, look, go ahead and raise these to the power of 2, add them together, boom, you get the hypotenuse as a square, right? Hypotenuse to the power of 2, which is true. It's just, I'm using a calculator for this. And so when you get a radical leg like this one, make sure to put these into parentheses. Otherwise, you're going to get the wrong answer, which I'll tell you what you would find if you did that. But we need to put these in parentheses in order to get the correct answer, okay? So I know 3 to the power of 2 is 9. That's fine. But when I put 2 times the square root of 10 in parentheses to the power of 2, it's going to give me back 40. Okay? If you did not use the parentheses, you would have gotten 20 out of this. And that's no good. 20 is not what this is as to the power of 2 right there, okay? So let's go and add those together, which is the hypotenuse as square. Hypotenuse to the power of 2. Oops. There we go. Well, I don't want, well, I guess we got to add those first, right? 9 plus 40, boom, 49. And this would be the hypotenuse squared to the power of 2, either way. So we don't want the hypotenuse to the power of 2, we just want the hypotenuse square rooted, okay? So again, the nice thing about that is it gets rid of the power of 2. And now I got the square root of 49. So we could say, hey, what multiplies by itself to get 49? It's 7. So even though this problem said, hey, we want the answer rounded to the nearest tenth and simplest radical form, that's it. It's just 7. Okay, so 7 is the hypotenuse right here. But again, I'll emphasize this because some students are still struggling from the last couple periods, saying, I'm getting the wrong answer, but they're forgetting to put the parentheses around this radical right here, the square root stuff, from this leg. But you're going to need them, especially if you're using the calculator. If you know how to do this otherwise, then you can do it in your head and get 40, that's fine, but for right now, we should be using the calculators. So we have to be able to do this on graphs as well, and it's so fun. So 2 points on a grid will make a hypotenuse of a right triangle. In fact, if you've ever connected 2 points on a graph to make a line segment, then it's possible that you've seen the right triangle that's created from those. But you'll see that the grid lines will make the legs, and actually the grid lines will make the 90-degree angle mark for us as well. So let's demonstrate this, okay? So I'm just going to make up a triangle on this one. I'll come up here. Let's use this point right up here. That's at -9, 8. Okay? And then just any other point we'll do, let's choose this one right here. That's at 2, -7. There we go. All right, if you connect these 2 points with a line or line segment, I use some technology because I suck at drawing lines. So there we go. Okay. This is the hypotenuse of a triangle. And you may say, well, what the crap are you talking about? Triangle right here. Again, it's created from the grid lines. Okay. As it turns out, if you were to take these and just kind of connect them together, it's almost like what we do with slope, like this. See that right triangle right there? And since I use technology, it's a lot prettier than if I had drawn it myself. And it creates the right triangle mark right here. There's other places, of course. But what I have in green right there is that right triangle, okay? So the 2 red sides, again, are the legs of this right triangle. And you can figure out the side lengths of these legs just by figuring out how far it is from this point to the edge here. Okay, so I would just count boxes, right? So you'd say, you count the boxes right here. Let's pretend like I'm counting these. And then this one right here would be 11. And then this one right here, if you were to count all the boxes, I mean, there's different ways to find the distance here, but what the heck is that, 15? Something like this. Now you have the 2 legs, and you're able to find the distance between those 2 points because of the Pythagorean theorem. Now, I'll specify this. It looked like a student brought the assignment to me from last period, and they said, hey, look, I drew the triangle above, which works. You'd get the same leg lengths if you were to draw the triangle here, but Canvas didn't want it. Okay, so don't draw your triangles above it, otherwise it's going to mark those incorrect. It's not that it is incorrect, it's just that the assignment doesn't know the difference. Stinking assignment, okay? But this is what we're going to be doing, and on the assignment you have to draw the 2 red lines on the grid as well, and then it allows you to put in the answers. So you're going to see a graph like this. It usually has, from what I remember, it has the 2 points already graphed. I could be wrong about that, so let's go ahead and go through graphing these. But once we get those graphed, we'll have to draw the 2 legs on the triangle, wherever that is. And then we fill in the 2 leg lengths, and then we have to figure out the hypotenuse with the Pythagorean theorem, okay? But it does want it in simplest radical form. Let's go ahead and get these 2 ordered pairs on the graph, okay? So I'm going to start with 4, -5. Which would be 4 to the right, down 5, boom, right there. Okay, and I'm starting from the origin. We can label that as 4, 5. And then it also said -1, -3, so 1 to the left, down 3, boom, right here, okay. All right, now that we got that, let's go ahead and connect those 2 points to make a hypotenuse. And now that we have that, and again, this, from what I recall, this is going to be already on the assignment. So you have to draw the 2 legs. Okay, so you have to draw this leg, and then you have to draw that leg. Not my best triangle with technology, but it'll do. Okay, now that we have that drawn, then it will allow you to start putting values into the boxes here. So let's go and do that. And all I'm going to do with this is just count. I'm going to start by counting the boxes. Okay, so I'm going to start on the left. That's 1, 2. That means that leg length is 2. I put 2 right here. Doesn't matter which of the 2 boxes you put the 2 in. It does not, from what I remember. Okay, but I have to find the length of the other leg. 1, 2, 3, 4, 5. That's a length of 5 right there. So my second leg is 5 units long. Now, last thing we need, because we got the drawing, we got the 2 legs, last thing we need is the hypotenuse. Boom, Pythagorean theorem. So for me, I'll say that the first leg here is 2, and you're just solving this. So again, if you put a 5 there, it's fine. Or if you switch the 2, that's good. Okay, but I'm going to have to raise these to the power of 2, add them together, and then that will give me the hypotenuse to the power of 2 as well. Okay. This one's not too bad. 2 to the power of 2 is 4. 5 to the power of 2, 25. It's just 5 times 5. If I add these together, again, I'm expecting the hypotenuse to the power of 2. Well, let's go and add these together. See what we get. 4 plus 25, 29er, and this is going to equal hypotenuse squared. Okay. Last thing, to solve this, we don't want just the hypotenuse to the power of 2. We just want the hypotenuse. So I'm going to square root that garbage. If I do it to one side, I got to do it the other side as well. This gives me just the hypotenuse, which is exactly what we wanted. Like it says there at the bottom, it's just the square root of 29. Now put that in the calculator just to double check. But yeah, it's going to give you back the square root of 29. And it wants this in simplest radical form. There it is. I found it. Square root of 29. So when you put this into the assignment for Canvas, you got to push this button first to get the square root symbol. It'll be blank, so just type in your 29, push enter, boom, you're good. So we're going to do the same process on this one. Let's get those points on the graph. Again, I don't think that you're going to have to do that yourself. But 6, 4, so 6 to the right, up 4, boom, right there. So that's the point 6, 4. And I also have the ordered pair 3, 2, which is here. 3, 2. Okay, well, let's go ahead and connect those to make the hypotenuse. It's kind of small. There we go. That's all right. I could do worse. And we need the 2 legs, right? There's one leg. There's another leg. Bam. Okay, so there's our right triangle. And again, it's even showing that square mark as the 90-degree angle, if you want to consider that. But let's find the leg lengths. So the last one I counted boxes. Of course, just like we've seen before, you could count lines. Meaning I'd start at this point, there's 1, 2. This one is 2. And then the other one, I'll start at this point, 1, 2, 3. This one's 3. Now notice it does not matter the direction because we're looking at lengths of a triangle. Lengths are never usually shown with negatives. So we only want these values to be positives. I'll say that my first leg is 3 and the second one is 2. Again, it doesn't matter which one you put those in. But now when using the Pythagorean theorem, I'll say that my first leg is 3 and my second leg is 2. So let's go and square those, add them together, and that's the hypotenuse as a square. Okay. Now, I think you guys have noticed, or maybe not, but we have been using the order of operations all along. Remember, you got to do exponents first. 3 to the power of 2, boom, 9. And then 2 to the power of 2 is 4. And then we add together because that's order of operations. Okay, so that's the hypotenuse squared. 9 plus 4 is 13. Now remember, this is the area of the square created by the hypotenuse, but we don't want the area of the square. We just want the hypotenuse. So this is where we're going to square root both sides. Okay, so I have the square root. Let's see if I can do this. Square root of 13, well, that's just the hypotenuse. And yeah, I put that in the calculator and it cannot be simplified. So that's it. Square root of 13 is our hypotenuse. Now, be aware, it's possible it may give you like 5 square root of 13, which in that case you'd have to put the 5 in there as well. But I think we've entered answers like that into the assignment already. So hopefully that isn't too new for us. We did not solve for leg lengths. You'll notice we were only solving for hypotenuses. We're going to do that next time. We're going to be solving for legs, which is why the mastery quiz on this stuff is after the next lesson. But you should be able to find the distance between 2 points on a coordinate grid as well, okay?